All right, we are live.
Yes, doctor.
Okay, let me check. Can you see my screen?
Yes, doctor.
All right, I'll get started. My name is Osama Muhammad. I'm a professor of civil engineering in Abu Dhabi University. Give you at the beginning a little bit of a background about myself before I get into today's topic. Received my bachelor's degree from the University of Khartoum in Sudan, Jamiat al-Khartoum, and then work as a consulting engineer for about 3 to 4 years in practice in Sudan, and then moved to the United States and started my master's at the University of Colorado in Denver. I spent 2 years there, finished my master's, and then joined the PhD program at the University of Colorado, but a different campus in Boulder City. And was involved in consulting also in civil engineering at that time. And after finishing my doctoral degree, PhD in Boulder, I moved to the University of Hartford. It's a small university in the northeast of the United States, in the state of Connecticut. I spent there about 6 years, where I was promoted to the associate professor rank, obtained my professional engineer license there, and then came to Abu Dhabi University in 2008, where I established the civil engineering program at Abu Dhabi University. It was a very small program at that time. We started with 50 students, and with time we grew to, there was a point of time when we reached about 650 students. That was at the peak of the employability market in UAE, and the demand for civil engineers was very high. I'm also active with the American Society of Civil Engineers. I'm a member of that society. I'm licensed also in the Commonwealth of Virginia in the United States. My professional license was obtained there in 2004. And it was an exciting experience here in Abu Dhabi University since 2008. So our talk today is about the civil engineering discipline and careers in civil engineering. What are the opportunities? So the goal of this presentation is really to give you an idea for our community about the discipline of civil engineering, but also at the same time talk about what it takes to succeed in civil engineering, what are the expectations, and also for our students, how to prepare themselves and plan for the future in this discipline. Planning begins while as a student and then continues after graduation. I'll talk about that soon. So let me begin by civil engineering itself, the big picture about the discipline itself. Civil engineers, I'm going to use the definition that is used by the American Society of Civil Engineers itself. Civil engineers design, that's the job number one. I'll talk about that also in detail. What does the degree in civil engineering, the Bachelor of Science in particular, entitles you, the graduate for? So primarily design, build, maintain, and in the language of ACE, the foundation of modern society. So that includes our roads, the bridges, the drinking water in terms of the quality of that water, the distribution of water, accessibility of water, and also energy systems, seaports and airports. All of these infrastructures, civil engineers are involved in their design, their construction, and their maintenance. This definition by ACE is hardly complete because civil engineers today are involved in much more than these tasks in particular. There is more to that. The discipline became very multidisciplinary. It is definitely, historically, has been connected to architecture, but certainly related to electrical engineering, nowadays computer engineering, biomedical engineering. Civil engineers are involved in all of these disciplines. So the big picture is that the engineers are designers. it touches your life in lots of ways. Again, using the language of ACE, for those who are not civil engineers, remember us every time you enter or leave any building. And you remember us starting from the safety of that building. That is, you are certainly assured that this building, by properly being designed and maintained, will not collapse over the heads of the users, alhamdulillah. And that is by proper design and proper training of the people involved in the design process. So when you enter with confidence that the building is safe, and when you leave it with confidence that it is remaining safe, remember the civil engineers. Of course, building is designed by a lot of people, including architects. The electrical system is done by electrical engineers. The mechanical system, air conditioning and heating, there is mechanical engineers, of course. And civil engineers comes to different aspects of it, but most importantly, the safety against collapse of that particular structure. Also remember us every time you drink water or shower, the quality of that water in terms of cleanliness, the accessibility to this water reaching your apartment, the system that is connecting it. So the network that is collecting the water, cleaning it, and distributing it all the way until it reaches your apartment, civil engineers are involved in that. And surprisingly, even when you flick the button in your apartment to turn on the light, that sounds like electrical engineering, but we are involved as well in that part. And there are lots of ways we're involved in the light coming on into your apartment. The least being the power transmission lines that are taking this power to the building next to the building where you live, and then of course getting into your apartment. Driving home to work, you're going to drive on roads designed and supervised and maintained by civil engineers. You're going to go across bridges that are definitely designed by civil engineers, primarily for safety. In addition to that, if you take the metro in Dubai or any part of the world, the team that is involved in the design of the system, from the access points to points where you leave the metro, to the bridges that are taking it, to the tunnels it goes through, all of these are the civil engineers. And on top of all that, when you toss the empty coffee cup in the recycling bin, we are involved in the recycling process. So civil engineers are touching your life each time. You will not be able to forget us. What are the sub-disciplines in civil engineering? To be able to affect people's life in so many ways, that means our sub-disciplines within civil engineering are numerous. This is really a partial list, and each university have emphasis. They focus on some of these things, but not everything. Transportation engineering and traffic, coastal engineering, structural engineering, environmental and water resources. Now they are connected together. There was a time when these were independent, but now they are coupled highly because of the overlap between these two systems. Geotechnical engineering and construction management and construction engineering. Architecture, maybe you wonder why is that in this list. It's a discipline by itself. Now there is a distinction between architecture and architectural engineering. There's distinction and overlap. Architecture is primarily for the design of the structure for lots of ways, including aesthetics of the structure, functionality. Architectural engineering gets into the safety design, structural design, constructability, materials, all of that. So in the United States, architectural engineering is under the American Society of Civil Engineers and accredited as an engineering discipline. And that is why it's here in our list. Utility engineering and surveying is a sub-discipline. Sometimes it's offered as an independent sub-discipline. under civil, so you specialize in this area, or you graduate as a civil engineer, but at the same time you practice in utility engineering and survey. So a graduate with a bachelor's of science in civil engineering, regardless of what was your capstone when you graduated, what were the elective you selected, you are entitled, once the degree is a Bachelor of Science in Civil Engineering, you are entitled to work in any of these sub-disciplines. But within short time, most people specialize. So after graduation, you can get into any of this discipline. But after that, within 1 or 2 years of work, you develop more experience in one area, and the majority of people continue in that particular area. There is no reason why you can not jump from one area to another. You can always do that. Your degree allows you to start as transportation engineer, 2 years later switch and become structural engineer, geotechnical engineer, and so on. So you can move from one discipline to another depending on your interest, depending on the interest of your employer, depending on the job market, any of these. So these are some of the areas that are part of the civil engineering discipline. So I'm going to talk about some of these disciplines one by one. I will not exhaust all the list. Starting from structural engineering, which is part of civil engineering. I started with structural engineering by a natural bias, by myself being a structural engineer. And of course, like our students here, I graduate as a civil engineer. And then worked in structural engineering most of the time, moved to construction management. And of course, construction engineering and management are highly connected. And got involved also a little bit in transportation engineering, but eventually returned fully to structural engineering. And that is my current specialization. However, even when you specialize in one area in civil engineering, the structural engineer or the transportation engineer is not waived from the requirement to know the other disciplines. Even when you proceed to professional licensure, I will touch on that also later, you are expected to know something about all of the disciplines of civil engineering years after you graduate and continue to work on one area. So what do structural engineers do? Job number one is to assure the safety of the structure. And by structure, we mean the building skeleton that is carrying the load in the building, or in a bridge, or in a power transmission line, or in a telecommunication tower, or a tunnel, the structure of the tunnel. All of these structures are always designed to ensure that they will be safe against collapse. Typically, this is not the only requirement. There is, when we design a system structurally, we are required to, number one, assure safety. As we always say, safety is job number one, but also serviceability. The system should function. There's certain definitions that function properly. And economy is always in the back of our minds. We know the cost of everything is rising. And for civil engineering, it has always been the case that we need to pay attention to the cost. So you don't go for the most expensive system because you want it to be safe and serviceable. What you do is you ensure safety and serviceability, but with an eye on the economy. So you are not going to be designing the most expensive system. So what the structural engineers do is they design buildings from a safety point of view, and design the bridges and design tunnels, things like that, to achieve these goals of safety. Most of the time, that design involves using computer programs to create the computer models. And nowadays, more than ever, there is no discipline in engineering or any other actually area where computers are not used extensively. And today, the starting point is always some kind of a computer program, eventually a set of computer programs. So this design process begins by simulating the system in a computer program and ends by describing what you want to build on drawings. So we produce drawings that include our requirements to assure the safety. So the drawings, along with written descriptions that we call specifications, if the structure is built this way, we are assuring the users that the structure is safe. So the translation of these drawings into built structures involves construction engineering and management. All right, and therefore the structural engineers are also well aware and trained of construction management and engineering aspects. So structural engineering is the discipline that that is mainly about the safety and serviceability of the structures. Another discipline in civil engineering is geotechnical engineering, one of the sub-disciplines of civil engineering. And basically geotechnical engineering about the properties of the soils and rock with an eye onto the fact that every structure that we build, a building or a bridge or a tunnel, must transfer that load and be supported by the soil. So it has to transfer the load into soil or rock, and therefore we need to ensure that the soil and rock are competent and capable of carrying that load safely without collapse. So a failure in the supporting system under the structure is going to be catastrophic because you don't get to see this failure until it happens, because the structure is founded on what we call foundation or footing. This foundation is under the structure, under the bridge and under the building, and therefore the failure is actually not seen necessarily, but actually definitely felt. And therefore geotechnical engineering is very important. So what geotechnical engineers do is they have the knowledge of the soil properties, the strength of the soil, they learn about the stability of these soils, so that everything you build on top of it is safe. Anything that is sloping, such as near highways, safety of embankments, the foundation for roadways, of the tunnels, of levees to protect the cities from oceans, of landfills, all of these eventually end up sitting on soils or rocks. And therefore, geotechnical engineering is an integral part of civil engineering. It's highly connected to all of the other disciplines. So our students here in Abu Dhabi University and all universities in the world take a minimum of one course in geotechnical engineering. And after graduation, they have the option to specialize in geotechnical engineering. More disciplines related to this, to civil engineering, is transportation, also one of the most popular disciplines. And you remember us, of course, easily because you drive on highways and on bridges also. Bridges are designed by structural engineers, transportation engineers, and also architects are involved in the aesthetics part of the bridge. One of the examples of bridges that involve a lot of rough disciplines is Sheikh Zayed Bridge here in Abu Dhabi. It's a beautiful structure designed by an architect. And of course, the structural engineers are responsible for the safety in terms of design. And absolutely, geotechnical engineers are there for the design, and of course, transportation engineers. So what they do is they do the planning and design, the operation, and the maintenance. Of course, these are done at stages. First, design, planning, and followed by design and operation. And of course, once the structure or the bridge or the highway is operational, maintenance needs are also determined, evaluated by the transportation engineers. So you're talking about roadways, railways, waterways, all of these are included. Other disciplines within that are part of transportation, actually connected to it, is traffic. And my friends in this discipline will correct me and say they are now becoming independent. But for us here, transportation and traffic are highly related by all means. So traffic, when you remember us, when you see those, like we said at the beginning of this presentation, when you see the highly synchronized traffic lights opening and closing in a perfect manner, the traffic engineers are part of it, and these are civil engineers. What is involved in the process? Similar to structures. Nowadays, we use computer programs to achieve that. But also on top of this, structural engineering, transportation engineering are highly governed by specific codes. We call them codes. And codes are developed by certain experienced bodies, so that if you follow these codes and procedures precisely, we end up with a product that is safe and also serviceable and economic. So transportation engineering is governed by codes. For example, AASHTO. AASHTO is one of the very popular codes in the United States and also used in lots of ways by the Department of Transport here in UAE. AASHTO is developed by the American Association of State Highway and Transportation Officials, very, very big name. So if you're going to design a bridge, AASHTO governs the process of the structural design of the bridge, the transportation aspects of the design, the drainage even of the bridge. So following these prescribed procedures is part of the instruction that are given to the student while pursuing the degree. More disciplines that are part of civil engineering. Very important discipline, subdiscipline is environmental engineering, and it involves lots of aspects. The keyword, we always begin by design. They design a system. They manage the systems of such as municipal water supplies. They are in charge of the recycling of the different aspects of our waste, typical waste, the disposal of the waste, the process of collecting the disposal, and treating that disposal to ensure the public health and safety. Pollution, air pollution control systems as part of the environmental engineering. Water pollution and how to protect against it, test it, evaluate it, is all part of the environmental engineering. To do that, environmental engineers need a number of sciences, including soil sciences. They learn also biology and chemistry. And also they need a lot of mathematics. And like all engineering disciplines, civil engineering, environmental, structural, transportation, and now environmental as well, all of these need significant mathematics. I also will touch on that soon. So environmental engineering, you can have a degree that is independent on environmental engineering. That is how involved this discipline is. So far, you graduate as a Bachelor of Science in Civil Engineering, you are entitled to practice as environmental engineer. The same discipline, I wanted to talk about the wastewater treatment within environmental engineering, which is a major part of the discipline, where all the water collected from the apartments, from industrial facilities, need to be collected and treated. And treatment means lots of things. One of them is basically removal of all of the suspended solids in the water collected from buildings and facilities. And this water has to be cleaned and treated so that it can be disposed of properly and safely, but sometimes to be reused as well, which today's goal is to minimize waste of water, because water is now becoming a major issue, or lack of water become a major issue, and water resources are critical. Students learn about design of these water treatment facilities. The picture on the left, on the top, this is very old-fashioned, big ones. But today there are more efficient, smaller wastewater treatment plants with the developments in electrical and computer engineering. The system on the bottom of the screen is smaller and more compact. The bigger ones can treat large amounts, and therefore they are still the favorite of people to use the old-fashioned bigger systems. Another discipline that is part of civil engineering, you can take courses specialized in this discipline, but you can also learn it by experience. And that is utility engineering and surveying. Now, utility engineering is becoming an evolving discipline because of the complexity of the utility system in today's cities. Utility, by that we mean the gas pipelines, the pipes that are collecting the fluids going back and forth from your apartments into the water treatment and water collection systems. All of this system now is running under cities, under roads, and becoming more and more complicated to manage. And now a discipline is emerging and evolving. It's called utility engineering. It focuses basically on the planning of these utilities under the ground, their positioning, how to design them to operate effectively, how to build them also, and during operation, how to operate them effectively. Most importantly, no doubt, whenever you have these kind of utilities, maintenance need. Leakage of gas, leakage of water is essentially a non-stop process. How do you access them easily to perform any maintenance operations necessary for them? So this discipline is emerging. It used to be in the past that you graduate with a degree in civil engineering, and without taking any additional courses, you learn how to manage utilities. But nowadays, many universities started to offer specialized courses on the management aspects and the operation and construction aspects for utilities. It is part of civil engineering because the sciences that you learn to plan, position, design, and construct utilities are pretty much the same that you need for environmental engineering and water resources and geotechnical engineering in lots of ways. So utilities include water, your gas lines, electrical grids, and other delivery systems for services. Then there is the coastal engineering. It's not really an emphasis in Abu Dhabi University, but it is a branch of civil engineering. And there is a lot of things that you do in coastal engineering, such as you design and manage the shoreline, anything that is happening on the shoreline, utilize the resources in the shoreline effectively to benefit the users. What activities do they need? Control erosion, improve navigation of channels and harbors, protect against flooding coming from the oceans, flooding caused by storms, control tides coming into the shoreline, and including also seismically triggered waves like tsunamis also. This is all becoming part of coastal engineering. Why is it still a branch of civil engineering? The sciences are the same that are needed from mathematics, science, fluid mechanics, geotechnical engineering, and also structures is needed to control this system. So this is the list is growing of what you can do with civil engineering. So I'm not going to add more disciplines and more areas where civil engineers can work. Actually, this list is not exhaustive by any means. There is a lot more that civil engineers do. So I just wanted to look at a couple of fascinating projects I personally liked. And it also has my bias as a structural engineer here. This long span bridge called the Milao Viaduct bridge that was completed in December of 2004 have lots of fascinating features, including the height of the support system reaching as high as 343 meters with the span length between the supporting points as high as 244 meters. This is really impressive. Of course, this is beside for you looking on this bridge, what might fascinate you is the beauty of the bridge, looking really fantastic here. And this bridge for us, from a design point of view, is not a simple design process. It takes time. I think it took about 2 years to complete the design. And then the design is done in phases. There's a phase, there's always initial design, followed by improvements, followed by changes requested by clients. So design itself is a continuous process. So the intriguing features of this bridge is the extreme height of the support system, height above ground, above the river that is crossing, and also the span length between supported points. Designing them is actually a challenge, as many civil engineers or students who are in our classes watching this presentation will say, well, this is amazing and definitely not easy to complete. Who is involved in the design? Definitely structural engineers, probably architects, and transportation engineers, no doubt, materials engineers. This is part of civil engineering. Geotechnical engineers, absolutely. So it's a collaborative effort in the design process. Other projects that are impressive, Burj Khalifa, of course, not to forget that. We are here in Abu Dhabi and UAE. And of course, you know, Burj Khalifa is still the tallest building in the world, the tallest freestanding structure in the world. From a design point of view, that height brings lots of challenges from design and construction point of view, both of them. How do you support such a massive, heavy structure that is built of nearly 330,000 cubic meter of concrete, 55,000 tons of steel reinforcement? This is really super heavy structure. And therefore, the design in all of its aspects is challenging. It has to be placed on a foundation that can take this load safely to the soil without failure. And this system consisted of what we call raft, a big thick slab. This is 3.7 meters thick slab sitting on 192 what we call piles, like vertical columns essentially, that went nearly 50 meters under the soil, into the soil, to transfer this tower, transfer the load of this tower into the soil. The design to resist lateral forces is one of the challenge. Well, lateral forces means earthquakes and wind. In particular, wind is a major design criteria for Burj Khalifa. And with height comes very high lateral forces from wind and probably from earthquakes also, and makes the design complicated. One of the features to make the design for wind resistance of this tall building successful is the Y shape from the plan view, looking at the top of the structure. It's one of the design features to reduce the wind forces. These wind forces increase with height of the tower and become a challenge. So Burj Khalifa is certainly a fascinating feature, as you would agree, and the design was certainly non-trivial. A team of designers is certainly involved in all aspects of design. And like I mentioned, the design will not start and end at one point only. The design is done at several phases during which updates and changes are necessary. Even after construction begins, design checks and updates are needed. Another interesting design is actually the tunnel, the one that connects the United Kingdom to France. All of you probably know about this tunnel, and the challenge of this tunnel is that it's going under the water to connect France to the UK, and that is about 50.5 kilometer railway, and that is really long and challenging. Definitely, geotechnical engineering is involved in the design process. Hydraulics and water engineering, coastal engineering, and certainly structural engineers. All of these are involved in the design process. So the part that is under the sea of those 50 kilometers, there is nearly 38 kilometers under the ocean. So represents challenges in lots of ways, including design and also construction, undoubtedly. So I'm next to certain that a large team of engineers have done a lot of calculations and modeling and simulation and testing also to ensure that this structure is safe, and it is luckily safe. I'm not going to put more structures to you except in the picture on the side, but I'm going to talk about this discipline. Bachelor of Science in Civil Engineering degree. When you graduate, what do you do as job number one? The degree itself, what does it mean? First of all, the degree by design, the Bachelor of Science, is a design degree. So it is actually a design degree, but it gives you also the tools to get involved into construction, operation, and maintenance. So as a graduate, the degree entitles you, first of all, for design. And design, the goals is to ensure the safety, serviceability, and economy of the structural system. To do that, to learn how to design, that degree has to be based on mathematics and science. So it's very rare that you get involved into design or get a degree that is design based without having sciences. So typically the sciences include physics, 1 or 2 courses in physics, chemistry, many times geology is also part of it, and mathematics. A lot of mathematics are involved. Calculus, definitely 2-3 courses in calculus. Algebra, matrix algebra in particular. Differential equations, no doubt. Total math courses is about 5, or sometimes some universities 6 courses. So a minimum of 3 sciences, and sometimes more. Minimum of 5 math courses is the basis. So this is how you tell, and I tell the students in my classes, how you tell your degree as a design degree is you see all of these math and science courses. And what I showed you for disciplines, all of them for design purposes need these courses as a basis. And of course, after you finish these courses, you work on the design, the courses in the discipline, which include courses in structural analysis and design, geotechnical engineering, fluids, environmental engineering and hydraulics, transportation engineering, and geotechnical and foundation engineering, and many other courses. All of these are on the design aspects. But I said that civil engineers are involved on the maintenance also and operation, and therefore they need at least 1 course in construction management, and it is mandatory to have a course in management. So all programs pretty much worldwide offer a course in construction management. I did speak about the goals of design of a structure system, that safety is job number 1, that when you build this structure, it is safe and also serviceable, or serving the goal of the design, and also economic. That is, you're not selecting the most expensive system. And therefore, a course in management is necessary. In particular, engineering management is one of the required courses actually in the discipline. Other supporting courses, in addition to all of these courses, there are courses that are related to ethics. We expect all projects in civil engineering to involve ethical questions and issues in terms of ensuring the safety and serviceability and economy, and construction also. And therefore, the ethics of the profession has to be observed and maintained. And therefore, ethics need to be taken as an independent course, like here in Abu Dhabi University, or embedded within other courses. And that is very common in many countries, to embed the ethics training into your courses. So the degree is based on science. All Bachelor of Science degrees, actually, worldwide, are anchored into science and mathematics. As a matter of fact, we tend to call engineering in general applied science and mathematics, the disciplines of applied science, mathematics and sciences. So that is the degree itself. Degree is challenging. So are all degrees in engineering. They're challenging. A lot of work. Of course, my students in the program will agree with that. A lot of discipline, but the title engineer is really worth it. The profession is worth it. So what I recommend, this is now for our students here, make the most out of those 4 years, more or less 4 years. Industry is becoming more demanding than ever. They're asking for more than the GPA now. So the GPA is just the starting point, and very soon it will disappear in terms of importance. After you graduate, I mean, what becomes important is what you know and what you can do. And what you know and what you can do is based on the skills that you build while a student in the university. Learning begins, as I will discuss in the next slide, begins also after graduation. It doesn't end upon graduation. So obtaining your degree is a license to practice and a license to learn. While pursuing your degree and focusing on learning as task number 1, get involved in activities that will help improve your skills, such as research. You get involved in the undergraduate research, for example, and that will give you the skills that you need in research, because the graduates don't end up only in professional practice. Some of them soon after graduation, or maybe years after graduation, go back to graduate school, and they might need to do research. And even while working in practice, there are times when you need to do research. Work with your faculty, give them something to say about you beyond what the GPA says or the grade says. Typically, when you graduate, some of you will need so-called recommendation letters. And yes, you might need those. And typically, faculty don't write just he or she is good. They write how are they good. And what is expected in the letter is not exactly the CGPA, because your employer gets to see that transcript. However, the letter will say the thing that the transcript doesn't say. All right, which is your qualities, your abilities, your personality, and so on. Extracurricular activities, I really encourage you to really find time to get involved. I understand that the degree is challenging. There are so many demands on your time, no doubt. But do find time for extracurricular activities that shape and build your character when you graduate. Do not forget, you're not looked at as a GPA only. You're looked at as a complete person with the skills and knowledge and abilities that can add to the employer. So lastly, I put together this system, what I'm showing here, what happens after graduation. Degree is obtained and you finish the celebration. One of the there are three things that can happen, actually more than that, but I just selected some of the possibilities. You may end up in construction practice. For some of you, even though your degree is design degree, you took some management courses, you can end up in construction. Your degree is actually a design degree, like I mentioned, and therefore you may end up going to the consulting practice, this route. And the preparation, essentially, most of it is for this, for consulting practice, because construction practice is something you can learn pretty much easily once you have the degree by doing it. That is a theory. The design part is challenging. That's why the degree is necessary. Some of you go straight to graduate school. I would recommend, with degree in engineering, to try to work first. But some of you actually do get straight there. Others have plans already to start their own business, yes, upon graduation, without working for anybody directly. After graduation, what happens is that the track will be more complex. From graduate school, finishing your master's, you might go back to consulting. Many have done that. Some have said, well, looks like I got a master's, why not do a PhD and go straight to academia for teaching and research? This is one of the paths. If you decide to go to consulting directly or construction practice, there is something that you need to do, and we call that continuous education and professional development. That applies to also people in academia. Because your knowledge that you gain at the bachelor's level is supplemented by your consulting practice or construction practice, but that is not sufficient. Engineering is an evolving field. Even codes of practice that are used for design keep changing. Construction practice methodology and technology is changing. So you cannot stop there. And that is the not so great news, that learning doesn't end by obtaining your degree. So wherever you are, you need to learn continuously. Another typical path that results from continuous education and became a requirement is professional licensure. For example, professional engineer license, PE, PEng in Canada, PE is in the US, PEng in Canada, chartered in UK. There are many, many others. Every country has a way to license engineers. And basically, this is saying that you have enough experience, you have taken enough continuous education that you become the engineer in charge. The responsibility for design becomes yours. That is the professional engineering license or PEng or charter. And there are many other responsibilities that are assigned to you. So you are a reference point in terms of the practice upon graduation. The requirement for licensure varies significantly from one country to another, but most of them require continuous education, experience also, and some require examination. United States definitely requires examination, and Canada for the most part also require another test. Yes. So after graduation, yes, after working, you take another test, and it's a significant one also to become licensed. So this is the path, and this is what I wanted to share with our community and our students. And I welcome any questions from the audience.
All right, guys. So if anyone has any questions or they would like to speak to the professor, then please raise your hand and we will unmute you so you can actually speak. Or you can actually write the questions in the Q&A or in the chat. Please feel free to do that.
Questions are welcome on any of these areas, especially I would say the path after graduation is important. While you think of any questions you might have, I would say do not decouple yourself from these here, which is ensuring that you have people who can write good recommendations about you because they know about you. Do not take the extracurricular activities lightly. It may sound like, well, I want the degree, I'm here for the degree, but there are lots of skills that you can build by participating in the activities. The clubs that we have here at ADU will help you also. Enhancing your communication skills is certainly, and I can cite cases where graduates with really very good GPA, and I consider them ready for practice, had difficulty in their job interviews, did not perform to their level. And that was really because they were not prepared to answer the questions. These activities will, such as research, such as extracurricular activities, will help you think out of the box and answer questions and communicate out of the exam setting. All of you are trained to take tests to do the projects, but there are lots of times when this is not the setting of the interview, and this is not the professional practice setting. When you work with the team, you are exchanging ideas, you are in front of your computers, but leaving your desk and asking another engineer or another professional technical questions. How do you ask the right questions, collect that data and reuse it? So nobody works alone today in today's practice. So these skills, talking to people, accepting also criticism, yes, that can happen, will happen. How do you take it, and how do you deal with it? How do you use it for your betterment? All of this doesn't come only from the classroom projects and tests and assignments. The last piece of advice is related to this discussion, which is, I know the measure of learning is a grade, A, B, C, and D. But it is a fact that not everybody is a good test taker. And I think you all know that sometimes test circumstances, I don't do well in a test. I panic in a test. You panic in a test. That can happen. So to avoid making the grade define you completely, you need to build all aspects of your character. And your success will not be controlled by your grade. Of course, getting an A is fantastic. If you don't get an A, that is not the end of the world. I can certainly say that you can be a very, very good engineer, and your grade was never an A. Okay, so far less than an A even, and you can still become a good engineer. And the examples are there in front of me, actually. EDU alumni, where I came from, Harvard, University of Harvard alumni. Many of them are still in touch. And not everybody who did super well in practice was necessarily 3.5 and above or consistent A. But they did learn a lot upon graduation. All right.
Yeah, thank you very much for the presentation, Dr. Osama. And we hope to see you soon in other presentations, inshallah. And I'm gonna stop the recording now.
Okay, thank you all for listening, and thank you, Ibrahim, for hosting me today.
Thank you, Doctor.